Welcome to Minimal Impact Design Standards Calculator Module 16, Routing BMPs in Series Treatment Trains. If you'd like to see other modules in the Minnesota Stormwater Manual, you can, in the manual, type in a search on MIDS Calculator Videos, or you can use this link here to get at the page that shows all of the other modules, and we'll show that to you later in this presentation. So in this module, we're going to go through a little bit of an overview of routing BMPs, what it is. In the Stormwater Manual, you can see this information in a section called Using the Treatment Train Approach to BMP Selection. I'm going to go there very quickly just to show you what this page looks like. So this is under the heading of Stormwater Treatment Concepts, and you can see there's multiple pages using the treatment train approach to BMP selection, and then 5 different scenarios for treatment trains for different types of settings. If you went to the main page on treatment trains, it talks about what a treatment train is, and it's basically, as the module says, it's just routing stormwater runoff from one BMP to the next until you get to the final product that you want. So I'm also going to talk a little bit about what the routing limitations are in the calculator, and then provide a routing example in the calculator. So routing is the process of discharging treated or untreated water from one BMP to another BMP. Basically, there's 3 types of best management practices in the calculator. The first are BMPs with underdrains. This is an example of a bioretention system with an underdrain. In this, water is captured, and the entire water quality volume may or may not be treated, but only a portion of that water is actually infiltrating below the underdrain. The remaining water, which is treated, goes to the underdrain and is returned to the stormwater system. These BMPs typically will not achieve your volume performance goal, and therefore you have to route that excess water to another BMP down the treatment train if you want to get the performance goal achievement. Another type of BMP are the infiltration practices. All the water that's captured in this BMP will be infiltrated, and therefore you don't have to route any of that water. It's going down into the underlying soil. However, this BMP, as well as any BMP, will only be designed to capture a certain amount of runoff. So if you design this to capture 1 inch of water, for example, and you get a 1.5 inch rain, you're only going to get that first inch. All the remaining water is going to bypass this BMP, and if you wanted to get treatment for that water, you would have to have another BMP down in the stormwater treatment train. Or if you undersized your practice, for example, to only capture 1/2 inch, it's only going to capture that 1/2 inch, and anything above that is going to have to be routed down in the treatment train process. Then we've got these other BMPs, sedimentation BMPs, that capture water and treat the water to remove phosphorus or TSS. They don't give you any volume reduction. So they do treat water, but all of the remaining water is discharged out of the system, and if you wanted to get volume reduction, you'd have to route it to a BMP down in the treatment train. And so that at the end of your treatment train, you may put in a system like this underground infiltration system to handle any excess water coming from BMPs that are upgraded of that best management practice. Some restrictions in the MIDS calculator: any BMP can be routed to another BMP except for the following conditions. You can only route a green roof to another green roof. You cannot route any other BMP to a green roof. No BMP can be routed to the disconnection BMP. So if you want to achieve the construction, if your goal is to meet the construction stormwater permit, you're not going to be able to use the disconnection BMP. And so you won't be able to route anything to that practice. You won't be able to route anything from the disconnection BMP to another BMP either. No BMP can be routed to a swale side slope. A swale side slope can only be routed to a swale, either a dry or a wet swale. A BMP cannot be routed to itself or to a stormwater treatment sequence that routes water back to the BMP. So in other words, you can't treat water and route that water down in the treatment train process and then have that water come back to the original BMP. That's not allowed. So for our example, we're going to assume we have a 30-acre residential area on sea soils adjoining a 3-acre ball field shown here, which is on A soils. We have 10 acres of impervious, and the remainder of the 30 acres is in turf. 3 acres is also going to be in turf. We're going to route the water from 50 roofs to lawns and gardens. We're going to have one large green roof in our system, maybe a commercial building, and we're going to route that into our swale system. We're going to have 4 biofiltration BMPs that are connected to these swales, so it might be a bioswale, or in the case that I'm going to show, it's going to be different biofiltration BMPs. And you'll see that when we run this example, there'll be excess water, and so we're going to run that to one underground system that underlies the ball field on the A soils. So at this point, I'm going to go into the MIDS calculator, and we're going to do this example. Again, you look for the MIDS calculator icon, double-click on it to open the calculator, go to File, and we're going to create a new file. We're going to call this one Routing Example. Hit Save, and the calculator will open. I'm going to maximize the screen to get rid of the background. And so if you've seen any of the other modules or used the calculator, you remember that you have to have 3 entries on this main screen in order to proceed into the calculator. First, are you using the calculator to determine compliance with the construction stormwater permit? I'm going to say no. Use zip code so that it can associate with the rainfall information. I'm going to use 55155 to my current location. And now our acreage is here. And if you remember, we had 3 acres of ball field, which was on A soil. We had 20 acres of pervious on a C soil. And we had 10 acres of impervious surface. So now I've got my acreages set up. This other information is optional. You can input here. The default values for the performance goal, phosphorus, and CSS can also be changed if you have site information different than what the default values are. So I'll click on my schematic tab now. And this allows me now to start working with my BMPs, and you'll see my acreages and my performance goal on the side. So I need to infiltrate about 40,000 cubic feet of water for this particular site. So I'm going to start by setting up all my BMPs and routing them, and then we'll take a look at how it looks in the routing before we actually go into each BMP and work with them. So our first one, remember, we're going to route 50 roofs, residential roofs, to turf areas. So we're going to go down and we're going to use the stormwater disconnection BMP for that. Click it on it and drag it onto the screen. That is eventually going to be routed to our swale. So we're going to have a swale side slope and a swale main channel. Remember, if you have a road, you might have a swale on both sides. You could combine this into one swale system. I wouldn't recommend doing that. There are some precautions you have to take if you start lumping BMPs, and we'll talk about that in a separate module. So I'm going to set up a second swale system for the other side of the road. If you remember, we had one large green roof. I'm going to click and drag that icon onto here. I'm going to open up my screen a little bit. It's not going to allow me to do that. So we'll move these around and get it looking good here in a minute once we start routing things. If you remember, we had 4 bioretention systems. In this case, just for the sake of brevity, I'm going to lump those 4 into a single BMP. I would recommend against doing that generally. I'll talk a little bit more about that when we get to the BMP itself. And then we're going to have an underground infiltration system at the bottom of this treatment drain. So now let's go in and let's do our routing. So I want to route this stormwater disconnection BMP to my swale. You'll remember one of the rules is I cannot route it to a swale side slope. I have to route it to the swale. So I'll take it to this first swale here. So you can see this is routing downstream BMP. I'll take it to the swale main channel. And you'll see the arrow pop up showing that this is being routed to that main channel. I want to route my green roof to that same BMP, again using the routing for the green BMP, the green roof BMP properties tab here. And the swale side slope, I want to route that to the swale main channel also. So I'm going to move these around just for visual purposes to make it look a little bit better. And so you can see that now I've got 3 BMPs coming into my swale main channel. I'm going to route this swale side slope to the other main channel. And you can see that that's happening. And now I'm going to route both of these swales to my bioretention system. You can see the options here. Now click here. Again, look and remember, you cannot route to another green roof or to a stormwater disconnection practice or to a swale side slope. So none of those 3 show up here as a routing option. I'm taking this to my bioretention system. And finally, at the end of the treatment drain, I'm going to route my bioretention to my underground infiltration. So now we'll take a look at this and make sure that everything is the way we want it to look. So we've got one swale system that's accepting water from the roofs, another swale system that's accepting water from the other side of the road, and it's all going to bioretention system, which then goes to an underground infiltration. Now I lumped all of the impervious disconnection into a single disconnection because I'm treating this as a single site where all the soils are the same. If in fact I have different soils, I would create multiple disconnection practices. But again, for the sake of brevity, I'm doing a little bit of lumping here. And you have to be very careful with lumping, and there's a separate module on that. So now I'm going to go in and work with each of these BMPs. Double click on the stormwater disconnection BMP. I've already done the routing. So I'm going to assume that I have 50 roofs, and each roof has 871 square foot footprint, which gives me 1 acre of roof. So I enter 1 acre of impervious surface here. We're going to be routing that to front yards, lawns, and we're going to have 2 acres of residential lawns that we're routing this to. I go to the BMP parameters tab, and it asks me for a few inputs here. How much impervious area am I routing? I'm routing all of my green roof, all of my roof surface, and that's 43,560 square feet or 1 acre, and I'm routing all of that to the 2 acres, which is 87,120 square feet. And you remember these are on C soils, so when I click OK there, you'll see that I'm getting some volume reduction, 2173 cubic feet. The performance goal for this was 3993, so I'm not getting my full performance goal, and that's why I'm routing this farther downstream in this treatment drain. I go to my green roof, and we're going to assume it is a large commercial building, 1/10 of an acre. So we'll put in 1/10 of an acre. You treat the green roof as impervious surface because the rain is falling directly on that surface. And we're going to have a media depth of 3 inches in this case. Again, it depends on what your site conditions are. It could be more, it could be less. And our media surface area, we're going to make the entire surface of this roof a green roof. You could route a conventional roof to the green roof. The conventional roof area cannot be larger than the green roof area, but in this case I'm assuming the entire roof area here is green roof. And you can see that I'm getting 359 cubic feet of treatment, pretty close to what my performance goal is, but still we have 40 cubic feet of extra water that we need to route into this system. I'll go to my first swale side slope, and if you have been to Module 7 where we talked about swales, you have to be careful here about routing your acreages. We're going to route all the acreage here to the swale side slope. Since we have a green roof that's taking up 1/10 of an acre on one side, we're going to put 4.4 acres of impervious surface here. We're going to go into the BMP parameters tab for the swale side slope, and we're going to input some values for that. I'm going to assume the side slope's 5:1. The flow path length for this I'm going to assume is 4 feet. I'm going to assume a channel length of 1,000. Again, this would all be site-specific information that you have, and this is just an example. And this is on a sea soil. We'll put it on turf, and you'll see that we're not going to get any treatment for a swale side slope. We're going to go to the main channel that this is being routed to. And let's take a look at this now. Now we're not going to input any acreages because the acreages have already been input for the other 3 BMPs. All that water from the green roof to disconnected BMP and the swale side slope is being routed to this BMP. And so you'll see that even without putting acreages in, we have 19,000 cubic feet of water coming into this system. The channel length is 1,000 feet to match the swale side slope. We're going to have a 3-foot wide bottom with a 2% slope, and the underlying soil is going to be a sea soil, 0.2 inches per hour. The vegetation will be mowed turf. We are not going to have check dams in the system. If you want to know how to use check dams, go to Module 7, which talks about swales. And so now I have routed everything to this BMP. I'm basically done with this part of my treatment train system. I'm going to go into my other swale side slope, and here I'm going to route 4.5 acres of impervious surface to this swale. The side slope again is 5:1. Same inputs as before. For the other side slope, 1,000 feet long, sea soil, and turf. I click OK, and then we go to this main channel. Again, no acreages because all the acreage has already been input into the side slope. We'll go to this inputs for this 1,000 foot long. The bottom width of 3 feet, 2% slope, an underlying soil of 0.2 of an inch per hour, and turf. Again, no to the check dams, and no to the bioretention base. So, I have my 2 swales set up, and they're both being routed now to bioretention. I'm going to go to the bioretention here, and I'm going to input 18 acres of pervious turf into this. No impervious cover coming into this BMP. Everything's being routed to this BMP. This might be a bioswale, so I'm assuming these bioretention systems are basically in line with the soil channels here. And you can see that this bioretention system has almost 37,000 cubic feet of water coming into it. Now again, I had mentioned an example that I would actually set up 4 separate bioretention basins, and that would be the preferred way to do it. For the sake of brevity, I'm going to combine the 4 into a single bioretention system. I'm going to use a raised underdrain, and it's going to be an unlined practice. So each of my bioretention basins was going to be 1,000 square feet. So if I have 4 of them, I'm going to input 4,000 square feet for my areas. I'm going to have an overflow depth on this of 1 foot, a total media depth of 2 feet. I'm going to input 0.8 for my underdrain depth, and I'll come back to that in a second and explain why that has to be my maximum value. I'm going to use a mid-range value for fuel capacity minus wilting point, mid-range value for porosity minus fuel capacity. Again, you'd have site-specific information here. No tree. I'm going to use mix AA. I'm going to assume it's a low phosphorus concentration. No amendment. To find out more about these particular inputs, go to the bioretention module in the calculator, or in the stormwater manual. And again, this is going to be on a sea soil. The drawdown time requirement is 48 hours. Now, if you remember, I had mentioned if I wanted to put 1 foot under the drain, I wouldn't be able to do that because I can only drain 0.8 of a foot in 48 hours. And so I'm restricted there. So I've got the system set up now so far. Here, let's go take a quick look at the results tab. And we'll see that right now I'm only getting 12% towards my performance goal, 18% annual volume removal. And I'm routing quite a bit of water at this point to my underground system here. Almost 35,000 cubic feet is going to my underground system. So I need to go into my underground infiltration BMP and set that up to either achieve the performance goal, or I'd have to go back and modify some of these upgradient BMPs or put other BMPs in here to get at my performance goal. I'm going to put this on 3 acres of turf. If you remember, that was a ball field that's on A soils. And I will go into my BMP parameters tab. Now this is an underground infiltration system. Module 6 describes how to come up with values for underground infiltration. You need to go into the manual, into an Excel spreadsheet, to come up with calculations for this term, this VP, which is underground pond storage device storage volume below the overflow, and to come up with engineered media surface area if you have media in your system. I'm not going to go into that Excel spreadsheet. If you want to learn how to do that, go to Module 6 and it will provide you an explanation. I'm going to assume that I have a system that has 10 100-foot long, 10-foot diameter pipes. And using that spreadsheet, I would have come up with a value of 28,374 cubic feet for this pipe storage. My overflow depth is 4 feet in this example, and I want to put media below this. And again, this value here, since I have media, this value would have to come out of that spreadsheet calculation. In this example, the spreadsheet would give me a value of 12,100 square feet. My media depth is 2 feet, and I'm going to have a porosity of 0.35. My underlying soil is an A soil. I must have typed the wrong number in here, so 0.35. And now I go to my soils. I'm going to put it on an A soil to draw down in 48 hours. I can infiltrate 6 feet, 4 feet in the pipe, plus the 2 feet in the media. I can infiltrate all of that in 48 hours. If I had 3 feet of media, I would not be able to infiltrate that. I'd get an error message. So we can see now that I am in fact achieving my performance goal. 35,000 cubic feet was what I needed. I've actually slightly over-designed the system. I'm getting about 36,800 cubic feet, and so I am achieving my performance goal. We'll click here on OK, and we will go into the Results tab for the entire site. And this provides a summary for the entire site now. And so this tells me my acreages, and my acreages are good. You can see them on the left here. I would have gotten an error message, or a warning, not an error message, but a warning coming in here if my acreages had not been correct. But you can see here now that I'm achieving 100% of my performance goal, and I'm getting 97% of my annual volume and 99% of my annual phosphorus and TSS. This BMP summary sheet here summarizes all of the routing that happens. For example, if we wanted to know what was happening with our green roof, we could see that we have 399 cubic feet is the volume it's receiving. It's achieving a reduction of 359 cubic feet, so it's got 40 cubic feet coming out. The bioretention system has 35,000 cubic feet coming out, and so forth and so on. So this table here is an accounting of the performance goal. Similar accounting is done on an annual basis for volume, phosphorus, and for TSS. I'm going to just quickly go back into my schematic tab and click on one of the BMPs. I'll click on bioretention here. If you want help at any point in the process here, you can click on the Help button or click on the links that are in the manual. Clicking on, here's an example of the link here. Clicking on the Help button, for example, will take you to a page in the manual that provides guidance on the specific BMP that you clicked on. In the manual, if you went to the table of contents and scrolled down to Minimal Impact Design Standards, clicked on that link, you'll see all the guidance for MIDS, including calculator guidance shown here, and then this page here, requirements, recommendations, and information for using different BMPs. You can access the calculator videos with that link right there. So returning now to the PowerPoint. Just a couple of tips here. Some good routing combinations that you can use in the manual, or in the calculator, I'm sorry, in the calculator. Green roof to permeable pavement or bioretention is a good routing combination, and these are not hard and fast rules. These are just some things that seem to have worked real well. Disconnection to swales. Again, you can't use the disconnection if you're trying to achieve a construction stormwater permit. Permeable pavement to tree trench. Swales with bioretention, which simulates bioswale. Underground infiltration is a good BMP at the end of the treatment train if the soils are suitable, as they were in the example that I showed. On lower permeable soils, harvest and use is a good end of treatment BMP because you can spread your water out over larger acreages if you have those acreages. For example, in the example with the ball field, we could have spread that water out over the 3-acre ball field. If volume is not a goal, but phosphorus removal is, iron-enhanced wet ponds or sand filters is a good polishing BMP. To view other modules in the manual, you can type in MIDS calculator videos in the search box in the manual, or you can go to this link here and it will take you to the other modules in the manual. That ends Module 16, Routing BMPs in Series.